A lot of students struggle with the concept of stoichiometry versus limiting reagent and when to do which. So you do a stoichiometric calculation when you know information about one substance, whereas you do a limiting reagent calculation if you have information about more than one substance. So let's go through an example. Let's pretend I tell you that water is formed from hydrogen gas and oxygen gas, which it is, and you begin with 5 grams of each reactant, and you want to know how much water can you form. Well, is this stoichiometry or is it limiting reagent? It has to be limiting reagent because you know the mass of each reactant. Okay, so you've got to do the stoichiometry calculations twice. You've got to calculate the mass of water formed from 5 grams of hydrogen gas and the mass of water formed from 5 grams of oxygen gas. If you didn't know this value right here, if you didn't know how much O2 you had, you just had an unlimited amount, for instance, you could just do this calculation once and be done. That would be an example of stoichiometry. Okay? But if you know the mass of this and the mass of this, you have to figure out which one you're going to run out of first. That's the premise of limiting reagent. So we've got to do our calculation twice. So we're going to do stoichiometry going from here to here. Then we're going to do stoichiometry going from here to here. And we're going to compare our answer. So here's the stoichiometry. There are 3 steps. Convert grams to moles. Using the molar mass of H2. So there's my answer. Carry out extra decimal places because we're going to be rounding at the end. Take that answer down here, multiplying by the mole ratio from the balanced chemical equation. Here we go. Take that answer. Now we're converting moles to grams. Molar mass of water is 18.016. Had a little bit of a mishap when I was typing that into my calculator there, so that's what that is. Even the teacher gets tired every now and then. And then you have to round your final answer to the correct number of significant figures. 2 sig figs here gives me 2 sig figs here. Now, again, if I didn't know the mass of O2, I'd be done. I'd say, okay, 44 grams of water form, and I'd go on about my day. But because I gave you the mass of O2, if you know the mass of both substances, you get to do this calculation series again, and then compare your final results. So, there's my balanced equation. I just rewrote it here. We're going to do through the stoichiometry again, going from here to here. So, grams to moles, there's the molar mass of O2. Mole ratio is now 1 to 2. And then moles back to grams. Again, I'm just having a rough evening here, typing in my stuff backwards. So I guess it's good for students to see the teacher make typos too, right? So now I round my final answer to 2 sig figs as well. So now I compare. From the 5 grams of H2, that produced 44 grams. And from the 5 grams of O2, that gave me 5.6 grams. So I always choose the smaller number, which means my theoretical yield, in other words, the maximum amount I can produce, is 5.6 grams. I hope this helps you with your stoichiometry versus limiting reagent.